The following video will be talking about how to get the area of a regular polygon when they are giving you apothems or apothms. Find the area of a regular octagon with apothom 12. So remember, the apothem or apothem is drawn from the center to a side and forms a right angle. So the first thing we're going to do is find the central angle. So the central angle in this particular case, since they are giving us an octagon, it's 360 divided by the number of sides. In this case, the number of sides is 8. So we have a 45-degree angle. Then we do the apothem split, and we cut that triangle into two congruent right triangles. So this 45-degree angle gets cut in half. And now it's a 22.5-degree angle because 45 divided by 2 is 22.5. So it's 22.5 degrees. So what we want to do, I'm just going to redraw this so it's a little bit easier to see. We have this apothem that's 12. We have the radius in blue. And then we have this side down here, x. Excuse me. Now, eventually, remember what we really want is if I take, I'm just going to kind of redraw that triangle that we have. I want to find the area of this triangle. So that means I need the apothem and I need the base. So that's all I really need. I don't need the radius. Even though it's there, I don't really need it. So now we're going to use SOHCAHTOA to find the necessary missing lengths. So the radius, while it's here, is not necessary. I only need to find the length of a side of this octagon, which is the base of this triangle. And then once I get that, I'll be able to figure out what the answer is. So this is going to be a tangent problem because if I'm using SOHCAHTOA, this is an angle. X is the opposite and 12 is the adjacent. One thing that's important to note, when we were doing regular hexagons, the radius and the base were the same, but that's only true in a regular hexagon. That's not true in a regular octagon or nonagon or anything else. It's only true in a regular hexagon. So I can't just find this and then say that that's the same length as the side length. The radius and the side length are only the same in a regular hexagon. So tangent of 22.5 equals x over 12. Then I multiply the 12 to both sides, and that gets me x. So x is equal to 4.97. Then I'm going to multiply that by 2, and as you see, I already did that on the calculator. So that's like 9.941. So that's the length of the base. So then, in order to find the area of this triangle, I'm going to do 1/2 times the base, which is like 9.941, times the height, which is the apothem. And remember, in this problem, the apothem was 12. So when I do 1/2 times 9.941 times 12, 1/2 base times height, I get 59.647 or so. This is the area of one triangle. Then I'm going to multiply that by 8. That will give me the final answer. So my answer for the area is 477.174 units squared. Let's do 2 more examples real quick. Find the area of a regular nonagon with apothem 10. So central angle of a nonagon. Central angle is 360 divided by the number of sides. A nonagon has 9 sides. So 360 divided by 9 is 40 degrees. Then I do the apothom split. 40 divided by 2 gets me a 20-degree angle. Now, I'm going to find x, just like I did in the last problem. So if I redraw the right triangle to be a little bit bigger, this is x, this is 10, and this is a 20-degree angle. So SOHCAHTOA, I'm going to use tangent because I have opposite over adjacent. So tangent of 20 degrees equals x over 10. I multiply both sides by 10. So I get 10 times the tangent of 20 equals x. That's 3.6397. I'm going to multiply that by 2 to get the whole length of this side. So that's like 7.28 about. And then, since I want to find the area of this triangle, and the apothem or apothem is 10, I'm going to do 1/2 times the base, which is about 7.28, times the height or apothem, which is 10, and I get 36.397. Then I take that and I multiply it by 9 because that's the number of triangles there are. Remember, if I drew this, I'm just going to do it real quick, but if I draw all the radii in this picture, I have 9 triangles. So the number of triangles is going to be exactly equal to the number of sides. So I multiply that by 9, and I get my final answer. So the area of this nonagon is 327.573 units squared. What if I have something that's way too big to draw? I mean, for most of us, we aren't even going to really want to draw a nonagon or an octagon. I already had those on the picture already, just because it's easy for me. But remember what we're doing all the time. Basically, what we do in every single problem is we draw a triangle, and then we figure out how many triangles there are. So since that's the case, I'm just going to draw one triangle, and then I'm just going to remember at the end to multiply it by 15 because there are going to be 15 triangles at the end. The apothem is 6, so that's a 6. Find the central angle, 360 divided by the number of sides. That gives me 24. Then I do the apothem split and I divide that by 2. So that's going to be 12 degrees. I want to find x. I do not care about the length of the radius because that's not going to help me find the area. So the tangent of x, the tangent of 12. Tangent of 12 degrees equals x over 6, multiply by 6. So x equals 6 times the tangent of 12. That's 1.27. So that's this length right here. Then I'm going to multiply that by 2 to get this entire length. So that's 2.55 about. So then I find the area of this triangle, 1/2 times 2.55 times 6. That gives me 7.652. And then how many triangles are there? 15 triangles. So I'm going to take that number, multiply it by 15, and I get my final answer. So the area of this 15-gon is 114.781 units squared.